Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is trigonometric functions. Moving forward from class 10 where we discussed the basic or the introduction to trigonometry, we discussed sine, cosine and tangent functions. This is a more advanced topic and in case this is your first video on trigonometry, I suggest you please go through my earlier video on trigonometry functions in class 10. In the present video, we'll first introduce you with a basic definition on angles. Let us start with that. What is angle? Angle is measured in degrees. 1 degree is equal to 60 minutes and it is written like this. One degree is equal to 60 minutes. Similarly, 1 minute is equal to 60 seconds. It is written like this. And we define now another way of defining angle with the term called as radian. So what is a radian and why it is required? If we can already measure angle in degrees, then why it is required to be measured in radian? We'll try to understand that. So 1 radian is defined as an angle subtended in a circle by a radius of unit length 1 against an arc length of 1 unit. So arc length is 1 unit, radius is 1 unit. So theta will be defined like this, arc length by radius. So this is the arc length, this is the radius, that is the angle in radians. So suppose arc length is in meter and radius is also in meter, then theta will be in radians. So angle subtended, let us take a complete circle where the angle is 360 degrees. So angle subtended is using this formula arc length by radius. So angle subtended in a circle is 360 degree. What is the arc length? Will be the complete circumference, which is 2 pi r divided by radius, which is r for a circle. So 360 degree will be 2 pi. So thus the formula of radian is 2 pi radian is equal to 360 degree or pi radian is equal to 180 degree. What is the value of pi? We already know pi is approximately equal to 22 by 7. But it is not the exact value. 22 by 7 is not the exact value of pi. Pi can also be approximated by value 3.1415. So let us convert other degrees into radian. So how to do it? Whenever degree is given, for example, say 30 degree, we multiply it by pi by 180 to get it into radian. So 30 into pi by 180 will be pi by 6 radian. Similarly, 45 into pi by 180 will be pi by 4 radian. 60 degree will be pi by 3 radians. 180 degree will be pi radians. And we already seen 360 degrees 2 pi radians. We can also reverse it. If pi radian is equal to 180 degree, 1 radian will be equal to 180 by pi. Which is, what is 180 by pi? Pi is 3.1415. So 180 by 3.1415 will be approximately equal to 57 degrees. Let us take some few examples. Now we want to convert the following degree measure to radian measure. So 20 degree is given. We want to convert it into radians. So already I have told you the formula. To convert degree into radians, we have to multiply it by pi by 180. So 20 into pi by 180 is pi by 9 radians. Similarly, 28 into pi by 180 will be 7 pi by 45 radians. We can simplify. 4 7s are 28 and 4 45s are 180. So it will be 7 by 45 pi radians. So we have understood now there are two ways to define angle. One is in degrees and one is in radians. But why do we require radians? it does not look very easy, because angles we know through protractor we can measure that angles, but how do we imagine a pi value? In later classes we will see that when you use pi, the simplification or computation will be much more easier than putting big values like 180 degree, 370, when different trigonometric functions are coming. Further, you will see in class 12 when derivatives are coming, use of pi as an angle is much easier. You will appreciate it later. Right now let us take it with a pinch of salt that we measure angle with degrees as well as radians. Later we will see the advantages of using radian as an angle. Now let us understand different values of sine and cosine using uh, pi values or the angle measured in radians. So we know that sine 0 is 0, sine 90 or sine pi by 2 is 1. Similarly, sine pi, it means sine 180 degree is 0, sine 270 degrees minus 1, sine 2 pi or sine 360 is 0. Similarly, we also know these cos values. We have studied earlier. Cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, cos 2 pi is 1. So what do we observe here? We observe that when sine 0 is 0 and sine 2 pi is also 0, sine pi is also 0, it means the value is repeating after every 2 pi. So sine 0 is 0, sine 2 pi is also 0. So we can write it is like this: sine 2n pi plus theta is equal to sine theta. What does it mean? What is n coming here? N is called the integer. It can take values from 1, 2, 3. Let us put n equal to 1. So what does it mean? Sine 2 pi plus theta is sine theta. So it is the values of sine is repeating after every 2 pi or after every 360 degree it is repeating. So 2 pi is also called as the period of the sine values. So this is the period of this function, sine function. So sine 2n pi plus theta is sine theta. Let n equal to 2. So sine 4 pi plus theta will be sine theta only. Similarly, we see that cos 2n plus pi theta equal to cos theta. Here also we see cos 0 is 1, cos 2 pi is 1. So after every 2 pi degrees movement or after every 360 degree, cos value becomes same as that earlier. So if at 0 it was 1, after 360 degree also it will be 1. Let us take what happens at cos 10 degree. Cos 10 degree will be some value, then cos 370 also will be the same value as cos 10. That is why it is called period of the trigonometric function. So these 2 pi is the period and n is the integer. Now let us define the general solution of a sine and cosine function. Sine 0 is 0. We have seen earlier sine pi is also 0, sine 2 pi is 0. So the general solution of sine x equal to 0 is x equal to n pi. It means if sine x is equal to 0, then x can take value n pi, where n is integer from 1 to n. So x can be pi. If you put n equal to 1, x can be 2 pi. X equal to 3 pi also will be 0. X equal to 4 pi also will be 0. Sin x will be 0 and so on. Let us try to do it for cos also. For cos pi by 2 we know it is 0. Similarly cos 3 pi by 2 is 0. So the general solution for cos x equal to 0 is x equal to 2n plus 1 pi by 2, where n is the integer starting from 1. Let us put n equal to 1. So it will be 2 plus 1, 3 pi by 2. Yes, it is 3 pi by 2. Let us put 2. So 2 into 2, 4 plus 1, 5 pi by 2. So cos 4 pi by 2 is also equal to 0. So this means that this is the general solution. Now another important thing you will study is the sign of trigonometric function. This is very important. You must understand this. Without this you cannot do further. So what does it mean? What is this I have written here? ASTC. Let us try to understand. These are the four quadrants I have made. This is the first quadrant, you know. First quadrant means 0 to 90 degree. What is second quadrant? Means angle measured from between 90 and 180 degree. Similarly, third quadrant is from 180 to 270 degree. What is fourth quadrant? 270 to 360 degree or the 0 degrees. So these are the four quadrants. We have studied in class 10 up to values of sine, cosine, tangent between 0 and 90 degree, and we saw all were positive. For example, let us take tan 45. Tan 45 was 1. Tan 45 degree is 1 and it was positive. In fact, sine 45, sine 60, cos 90, all are positive values. So in the first quadrant, all sine, cosine, tangent, cosecant, secant, cot, all will be positive. This is very important. Now, what happens in second quadrant? In second quadrant, only sine will be positive. For example, let us take any angle between 90 and 180. Let us take 145 degree. So if I find the value of sine 145, it will be definitely positive. That much we can ensure, but we have to find that value, but it will be definitely positive. Similarly, we know cosecant theta is 1 over sine theta, that also will be positive. So let us say that sine is positive in this quadrant. What happens if I say cos 145? Cos 145 will be definitely a negative value because in this quadrant only sine is positive. What will happen to tan 145? Tan 145 also will be a negative value because in this quadrant only sine is positive. What happens in the third quadrant? In the third quadrant only tan will be positive. For example, let us take any angle, say 200 degree in this quadrant. What will happen to cos 200? Cos 200 will always be negative here. Only tan 200 or tan 230 will be positive here. Any angle between 180 and 270. I am just giving few examples. Similarly, in fourth quadrant, only cosine term will be positive. If cosine is positive, secant will be positive always. So we remember, how do we remember? Bit confusing. It is easy to remember. Remember ASTC. First, second, third quadrant. Write ASTC. All positive, sine positive, tan positive, cosine positive. So how do we remember ASTC? You can remember it as all student take coffee. I used to remember like this. All student take coffee. So all are positive, sine is positive, tan is positive, only cos is positive. Let us try to understand this with few examples. Now, in this problem, if cos x equal to minus 3 by 5 x lies in the third quadrant. X is some angle. Find the values of other 5 trigonometric function in this quadrant. So x lies in the third quadrant. This is third quadrant. We know only tan is positive. All other sine, cosine, cosecant, secant will be negative only. So that's what we have written. 6x is in third quadrant. Sine and cos will be negative. Only tan will be positive. Now cos x is given as minus 3 by 5. We know this identity, sine square x plus cos square x is 1. So we substitute the value of minus 3 by 5 here. And we'll get sine x equal to plus minus square root 16 by 25 or sine x equal to plus minus 4 by 5. But we know x is in third quadrant. In third quadrant only tan is positive. So sine x has to be negative. Therefore sine x is equal to minus 4 by 5. Now if sine x is minus 4 by 5, tan x, cos x is minus 3 by 5, we can write tan x, sin x by cos x. Just substitute the value and get it as 4 by 3. In third quadrant, this value is always positive. So it is 4 by 3. No negative term is there. Similarly, cot x is 1 over tan x. So it will become 3 by 4. Again, this is positive because axis is in third quadrant. Similarly, cosecant x is 1 over sine x, which is 1 by minus 4 by 5 or minus 5 by 4. Since it is in third quadrant, cosecant and secant both are negative. So we see the answer both as negative. Now there are a few more functions called as the odd and even properties. Like we see cos of minus x is equal to cos x. So this is called an even function. Why it is called even function? We'll see later. We'll understand this in more details later. Right now just I am giving the definitions. Similarly sine x, sine of minus x is minus sine x and tan of minus x is minus tan x. So sine and tan are called odd functions, whereas cos is called as even function. Now here also some another few properties are there, like cos pi minus x is minus cos x, cos pi plus x is minus cos x. You will see different formulas. It looks a bit confusing, so there must be some rule to understand this. Yes, there is a one very simple rule through which you can understand all formulas. For example, this table. I am just trying to tell you how this table is to be read as. For example, sine 90 minus alpha, answer is plus cos alpha. Similarly, sine 180 minus alpha is plus sine alpha. Sine 180 plus alpha is minus sine alpha. You may be wondering how to remember. Sometimes it is coming plus, sometimes minus, sometimes sine is becoming cos, sometimes sine is remaining as sine. So how do we remember? How to remember this full table? There is a simple rule which I am going to tell you now. Please remember, for relations 90 and 270, if the relation is with 90 and 270, sine will change to cos and cos will change to sine. So here you see sine of 270 minus alpha sine of 90 minus alpha will be cos. Sine will change to cos and sine 90 plus alpha is plus cos alpha. Similarly, sine 270 minus alpha is minus cos alpha and 270 plus is minus cos. Now the question comes when to put plus and when to minus. So first rule is, if the angle is 90 minus alpha or 90 plus alpha or 270 minus alpha, 270 plus alpha, sine will change to cos and cos will change to sine. Okay. So cos will change to sine. You can see here. Cos will change to sine and cos will change to sine when 90 and 270 angles are given. Okay, so what is the second rule? Second rule is we have to see the quadrant rule. So 90 minus alpha is in first quadrant. Let us assume alpha is between 0 and 90. So 90 minus alpha and 90 minus alpha is always in the first quadrant. In the first quadrant, all are positive. You will see everything positive here. What happens 90 plus alpha? 90 plus alpha is in second quadrant where only sine is positive. So only sine is positive means sine 90 plus alpha will be plus cos alpha and all other terms you will see negative only. This is very similarly 270 minus alpha, let us see. This will be in third quadrant. This will be in third quadrant. So sine will become cos, cos will become sine, tan will become cot, cot will become tan. We have seen for 90 and 270, but sine will depend upon the quadrant rule. Let us see 270 minus alpha, this will be in third quadrant. Third quadrant only tan is positive. So only tan and cot will be positive, all will become negative. Similarly 270 plus alpha is in fourth quadrant. In fourth quadrant only cos is positive. So only cos this will be positive. All other terms are becoming negative. What happens in 180 case? 180 minus alpha and 180 plus alpha. Sine will remain sine, cos will remain cos, tan will remain tan, and cot will remain cot. Only sine, again we have to see quadrant rule. Let us see quadrant rule and try to apply here 180 plus alpha. Sine 180 plus alpha is, first is sine alpha will be there because 180 and 360, sine will remain sine, cos will remain cos, tan will remain tan. Similarly, sine will remain sine here, but sine will change according to quadrant rule. So 180 plus alpha is third quadrant. Only tan will be positive, tan and cot. All will be changing to negative. So sine 180 plus alpha, sine will remain sine and negative sign will come because of the quadrant rule. So this way we are remembering all these formula. If you do little bit of practice, you can remember it lifelong. It is not difficult. Now, there are few more formulas. We call it as sum and difference formula. What is that sum and difference formula? Here it is like that. Alpha and beta are two angles. So sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Similarly, there are other formulas like tan alpha plus beta is tan alpha plus tan beta, 1 minus tan alpha tan beta. So these formulas you have to mug up, or maybe you can by heart. This is required to be by hearted. But with little practice, you will remember. Let us conclude this video with one simple example. We want to find the value of tan 13 pi by 12. So how to do it? Tan 13 pi by 12 can be written as tan pi plus pi by 12. Let us simplify this. 12 into pi is 12 pi plus pi 13 pi by 12. Yeah, this is correct. Now this is tan 180 plus theta. Tan 180 plus theta is in third quadrant. In third quadrant where pi is there, tan will remain tan. So positive sign is there, positive tan pi by 12. That is tan pi plus theta is tan theta. We have seen earlier for 180 degree and for 270 degree tan will remain tan. And since it is in the third quadrant, it will be plus tan theta. So tan pi by 12. Further, we can write it as pi by 12 as tan pi by 4 minus pi by 6. You can simplify with LCM and you will get it as pi by 12 only. Now this is tan A minus B formula. We know tan A minus B is tan A minus tan B, 1 plus tan A tan B divided by his sign is there. So what is tan pi by 4? Pi by 4 is 45 degrees. So tan 45 is tan 45 is plus 1. So plus 1 is written here, and tan 180 by 6 is 30 degree. Tan 30 is 1 by root 3. So we substitute the value of pi by 4 and pi by 6 and simplify it to 2 minus root 3. Friends, with this we conclude this video. In the next video we will go step by step into all NCERT problem solutions. We will give explanation for each of the problems. So please do not miss out those videos, friends, and please like this video and subscribe my channel. Thank you very much, friends.